In the last video, we were left here with the row echelon form of our original equation, which was here. So this original system of x minus 2y plus 3z equals 9, negative x plus 3y equals negative 4, and 2x minus 5y plus 5z equals 17 is equivalent to this system x minus 2y plus 3z equals 9, y plus 3z equals 5, and z equals 2. This is its row echelon form, and this is easily solved by back substitution. And actually, we have solved this as this is the system that we use in the example for back substitution. So, I'm just going to write the answer that our x value equals 1. Oops, sorry. There you go. X value equals 1, y equals negative 1, and z equals 2. So there. This time, it's your turn now to solve a system using Gaussian elimination. Pause the video and try to solve the system by Gaussian elimination. Alright, so we're now going to solve the system by Gaussian elimination. It's more difficult since all three variables are present in all the equations. So we can just write them down as is. We don't need to rewrite them because more or less they are aligned. Our target again is to make sure that it looks like an inverted staircase like that. So we need to eliminate these two leading terms first. So to have it in the second one, eliminate the second one rather, I would need to multiply the first one by negative 2. So when I add it, it becomes 0. And for the third one, I'm going to use a different color. For the third one, all I need to do is subtract equations 1 and 3 so that it also becomes 0. Now, you can actually do the operations to get row echelon form simultaneously. That is, if you can do it simultaneously and you will not get confused as to what's happening. So that's what we will do. So to have this in row echelon form, I will have first equation 2 because that's what I want to change to be the sum rather of negative 2 times equation 1 plus equation 2. That will result to 0. While equation 3 would simply be equation 1, there you go, minus equation 2. So that will just be 0. Now, just take note that subtracting is the same, I'm going to write it here, as equation 1 plus the negative of equation 2. So this follows actually the third operation, adding by a multiple, but the multiple is negative 1. So let's now do our operations. So first equation 1 is not touched, 3x2 plus x sub 3 equals 1. Then our equation 2 will have negative 2 times x sub 1 is negative 2x sub 1 plus 2x sub 1, that's 0, no need to write. Negative 2 times negative 3x sub 2, that would be 6x sub 2, minus, plus negative x sub 2, that will give us a 5x sub 2, then x sub 3 times negative 2, here you go here, is negative 2x sub 3, plus negative 2x sub 3 is minus 4x sub 3, that's equals negative 2 times 1 is negative 2 plus 2, 0. And now for equation 3, we just need to subtract. X sub 1 minus x sub 1, that's 0, I don't need to write. Negative 3 minus 2 is negative 5x sub 2, and x sub 3 minus negative x sub 3 is positive 4 x sub 3, 1 minus negative 1, that is 2. So now I will need to eliminate this part. And as you can see, I can add the 2. So 5 plus negative 5 will become 0. So therefore, I'm going to write it here. Only equation 3 is the one that I will move. That will be equation 2 plus equation 3. So the first equation is not touched again. There you go. And the second equation is not touched as well. So I will just have it here equals 0. And the third equation. So 5x sub 2 plus negative 5x sub 2 is 0. No need to write that. Negative 4x sub 3 plus 4x sub 3 is equal to 0. Oh, this is 0. And 0 plus 2 is 2. Now, we have this equation again, but we know that 0 is not equal to 2. Therefore, we can't have values of x sub 1, x sub 2, and x sub 3 that can satisfy all three equations at the same time. Therefore, we say that this system is inconsistent. Thus, therefore, this system has no solution. Let's have one last example of Gaussian elimination. So, pause the video and try to solve this system by Gaussian elimination. Alright, so before we actually head to Gaussian elimination, first take a look at the first equation. We can actually solve this already as x sub 2 equals x sub 3 once we transpose. That should give us a hint already. And because of this, we can actually do some back substitution already without going through Gaussian elimination. So in doing so, what we would have would be, I can replace this x sub 3 with x sub 2, so I can have x sub 1 minus 3x sub 2 equals negative 1. And negative x sub 1, I will retain the third equation, plus 3x sub 2 equals 1. And if you will also notice, and probably this also happened in your Gaussian elimination, if I'm going to add this equation, it will become 0 equals 0, or somewhere along your elimination, you've reached 0 equals 0. This indicates that the equation is always true, and hence any real number with a certain combination will be able to work in this system. Now, let's go back to the basic equation of this one. You can actually choose any, but I will choose the second one. And take note, we already took x sub 3 as our free variable. And here, we're solving now for x sub 1, given that x sub 3 is equal to x sub 2. So therefore, I will transpose this one here. I will have x sub 1 is equal to negative 1 plus 3x sub 2. So therefore, I finally have my solutions. First, I can have x sub 3 be equal to, actually x sub 2, but I will first let x sub 3 be equal to t, where t is an element of the set of real numbers. And since x sub 2 and x sub 3 are equal, I can also have x sub 2 same equal to t, also an element of the set of real numbers. And finally, x sub 1 will be equal to negative 1 plus 3t, or 3t minus 1. And as you might notice, this is actually a consistent and dependent system because we have infinitely many solutions. And that's how we solve system of equations using Gaussian elimination.